Hello and welcome to a Second Look Math. Today we're taking a second look at the probability of dependent events. We have a word problem here. Micah has one blue chip, one yellow chip, and two red chips in a box. She picks two chips at random. What is the probability of her picking the blue chip and the yellow chip? Now, when we have a probability problem like this, I think it's important to envision exactly what's going on. So we're going to start out here by drawing the four chips. We have one blue, one yellow, and two red. Now, one way to envision a probability problem unfolding is with a decision tree. And this decision tree is going to show the sample space of possible outcomes. She's picking two chips at random. This is telling me that this is not a simple event, but instead a compound event. So it's going to involve two decisions, or two choices, two draws from this box. In order to get the first decision, I'm going to draw a tree with four different possibilities. These four possibilities match up with each of the individual chips. So I'm going to put these chips on each of the four possibilities. Now we have the first decision could be when she draws a blue, a yellow, or it could be either one of the reds. After this, we have a second chip being drawn. So if we can envision the first chip being drawn as this blue one, then a second decision is going to be made from that blue chip. After drawing the blue one, there is no mention in the problem of replacing any chips. So if Micah grabbed the blue chip first, then she has left only a few different options. She has the yellow one left, the red one, or the other red one. That's if the blue chip was drawn first. Now we can envision the same process happening for each of the other chips. If the yellow one, for example, was selected first, so we'll cross off the yellow one, then those three other decisions or options will be the three other chips that are left. So yellow being gone leaves me with blue, red, and red. The same thing happens with the red chip. If the red chips are gone, then so we can cross one of those off, then we have blue, yellow, and the other red. Same thing for the last one, so we can fill those in. Now we have the two different draws. So this is draw one here, and then this second row or second column represents draw two. So we have draw one in this first, and then draw two. This decision tree represents the entire set of possible outcomes that Micah could draw. So we have a equation here that can actually represent the same situation. But before we get into that, I want to highlight once again the possible ways that these two events could unfold. So we have Micah could draw a blue, then a yellow. She could draw a blue, then a red. A blue, then she could draw the other red. So there's kind of two possible options of her drawing blue, then red. And this can continue all the way down. If she drew yellow first, then she could have the blue next, yellow, then the red next, yellow, then the other red next. So she has two options where red could be second. This continues all the way down the tree, leaving her with a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 possible combinations. Of these 12 combinations, only a few actually involve what the problem is asking, a blue chip and then a yellow chip. In fact, blue chip and then yellow chip happens only one time in the entire set of 12. So we would expect blue then yellow to happen 1 out of 12 times, and that would be the probability that we would expect based on our drawing. So now we can get into this equation that's written over here on the right. So knowing this 112 is in our mind as our probable answer here, we can look at the equation and see if it will match the same idea. So in this equation we have the probability of two dependent events. That is the probability of blue happening and and yellow happening. B is yellow happening. So I've color coded those. The probability of event A being the blue chip happening, is a 1 out of 4 happening, because there's one blue chip out of 4 chips. Now, if we pick this one, as we did before, we can cross this one off, and that leaves 3 other options. And the possibility that yellow will happen is 1 of those 3. So the possibility of yellow happening is 1 out of 3. So the probability of the blue happening first was 1 out of 4, and the probability of yellow happening second is 1 out of 3. This, when multiplied together, top times the top, bottom times the bottom, gives me that 1/12, which is exactly what we expected. When we look at our decision tree, we see 1 time out of 12 that blue and then yellow happens. And when we're looking at our equation, we have the probability of the first event times the probability of the second event gives us 1 out of 12 as well. And so when looking at the question, what is the probability of her picking the blue chip and the yellow chip, the probability is 1 out of 12. And that is a second look at the probability of dependent events. After filming this video, a couple misunderstandings came to my attention. This is a misunderstanding alert. It is very important to note that in this drawing, we are actually talking about the probability of a blue chip and then a yellow chip, because we said the answer was 1 out of 12, 1/12, and that is true, that blue then yellow happens, as we see here in this picture, 1 out of 12 times. But some of you who are very perceptive may have also noticed that yellow then blue happens 1 time, which would make this 2 out of 12, or 1/6. But the question should really say a blue chip and then a yellow chip, because when you are doing the probability of 2 dependent events, those events' order matters. And so that is your potential misunderstanding alert.